Okay, so in this section or in this video we're going to learn how to calculate the derivative of functions of the form f of x over g of x, where f and g are differentiable and g is not 0 at the particular x we're taking a derivative at. So the way you do it is you grab the bottom times the derivative of the top minus, then copy the top and multiply times the derivative of the bottom and divide everything times the bottom squared or the denominator squared. Okay, so let's just apply that to this function. And so we calculate the derivative and we have derivative of the numerator, or the top, is 1 times the bottom, x squared minus 1, minus, and you have to do the derivative of the bottom times the top. So derivative of the bottom is going to be derivative of x squared, which is 2x, plus the derivative of negative 1, which is 0, so just 2x, times the top, so x, all over the bottom squared. So copy the bottom, put it in parentheses, and square it. So now we're going to simplify this, and the way we simplify it is by distributing each of these products. So firstly we have x squared minus 1 minus, and then 2x times x is going to be 2x squared divided by x squared minus 1 squared. And then we just notice that x squared minus 2x squared is going to be negative x squared, then minus 1 all over x squared minus 1 squared. And so you can write your derivative as just put that negative outside, factor it out, and write x squared plus 1 over x squared minus 1 squared. And there you have your derivative. So it's basically just following that same formula. So let's do a few more and let's see how that goes. So for example here, if you have this function, in this case a function of t, you have f prime of t is going to be derivative of the numerator, which is 1, times the denominator, or the bottom, minus derivative of the bottom, which is going to be derivative of 5 is 0, plus derivative of 2t, which is 2, times the top, all over the bottom squared. That is the derivative of that quotient right there. And don't forget to calculate the derivative also of that minus 2t to the fourth. And for that one, you just do regular power rule, and you get 4 times 2, I guess I missed this 2 right here. So 4 times 2, which would be then 8. Sorry about that little mistake, but we can simplify now. And we have 5 plus 2t minus 2t, it goes away. And then you have 5 plus 2t squared minus 8t cubed. Okay. Now, and that would be your derivative, by the way. Now, this expression right here, you could do it in several ways. I think in this case, you could do product rule and consider this one term and this another term. You could rewrite it as a quotient by writing it as x to the fourth minus 5x cubed plus 10x minus 2, and divide it out by, well, the 5 multiplies that, so I should put it here, and then x to the negative 3, which is x cubed here. Okay. All right. Now, this is a quotient. You could apply quotient rule to it, or you could also just distribute that and divide term by term, and you'd have x to the fourth divided by x cubed, which is going to be x minus then 5x cubed over x cubed, 5, plus 10x over x squared is going to be 10x to the negative 2, and lastly minus 2x to the negative 3. So I basically write it all in terms of powers of x so that I can apply power rule, and that's probably the easiest way to do it. I recommend that you always try to see if you could do power rule first. If you cannot do power rule, look into product rule. If you cannot do product rule, look into quotient rule, but always try to do what is simplest first. So then the derivative here would just be 5 times derivative of x1, and then plus 10 times the derivative of x to the negative 2, which is going to be negative 2x to negative 2 minus 1, which is negative 3, and then minus 2 times, then lower the negative 3, x to negative 3 minus 1, negative 4. And then you just distribute things, and believe this is 5 times 1 plus, or sorry, minus. You're going to multiply the 10 times the negative 2, so minus 20 over x cubed. And then you're going to have plus 6 over x to the 4th. And that gives you your derivative very, very easily. So keep in mind that there may be some expressions when you have just an x in the denominator, like here, and in that case you may want to distribute that x and divide term by term so that you obtain something a lot easier to differentiate. So that's something to keep in mind. But anyways, that's good enough for the quotient rule. If you have any questions, please let me know in the comments, and that's that.